So let's talk about something that's about to completely change the game in AI. We're not just talking about a minor upgrade here. We're talking about a genuine breakthrough, a total revolution that could reshape the entire industry and, get this, save over $100 billion a year. So what on earth is it?
Well, before we dive in, we've got to ask a pretty serious question. The way we're building AI right now is, incredibly powerful, but it's also a beast to run. It chews through resources, needs these massive data centers, and consumes the same amount of power as a small city. You have to wonder, is this really sustainable in the long run?
But what if we could flip that script? What if there was a way to slash AI's energy use, not by a little bit, but by a staggering 80%? That's not a typo, 80%. That's the incredible potential sitting at the heart of the paradigm shift we're going to unpack today.
Okay, so before we get to the fix, we really need to get our heads around the problem. Because right now, the standard approach to AI has created this sort of hidden crisis of inefficiency and just mind-boggling cost.
Really, it's a tale of two systems. On one side, you have the old way, classical AI. It's kind of a jumbled mess of different pipelines, all relying on these gigantic data centers, and the whole thing operates as this mysterious black box we can't really see inside of. The alternative? It's something called the semiotic web, a unified, totally transparent system that's built from the ground up to be efficient and distributed.
Let's break that down. To train a big model like GPT-4, you're looking at something like 50,000 megawatt hours of energy. It's a huge number. Then, the systems AI uses to pull in information, they're called RAG systems, they add even more work for the computers. And after all of that, we have to burn even more power with a separate process just to try and figure out how the AI got its answer. It's this vicious cycle of spending more and more.
So how do we break that cycle? Well, the answer is kind of brilliant. It lies in a completely new way of representing meaning itself, a concept they're calling semantic DNA.
Okay, so what you're looking at here is a picture of how this new system works. It's a self-correcting feedback loop. At its very core, you have this semantic DNA. Now, this DNA is built from these fundamental units of meaning. We'll get to those in a second. From there, the system is constantly updating itself in a way that's totally verifiable, creating a dynamic system of meaning that you can actually trust.
So what is that fundamental building block? It's called a tokum. The best way to think about it is like a single, unbreakable unit of meaning. But it's not just a word. It's a core idea that's been given its own unique, verifiable digital fingerprint. Imagine a universal barcode for an idea, like gravity or justice. That's a tokum, and it is the absolute key to this entire new architecture. And what actually creates these tokums? Well, that's where the magic happens. It's the job of the core algorithm that makes all of this possible, the Tokumizer. This is the engine that actually forges these atomic units of meaning. And you can really see the difference side by side. Where classical AI is fragmented, the semiotic web is unified. Where the old models are opaque black boxes, this new way offers transparency right out of the box. And where traditional AI is this expensive, multi-step process, the Tokumizer does its job in one single, super efficient operation. Now, this might look complicated, but it points to a massive mathematical breakthrough. See, current AI is all about approximation. It's always making a best guess. This new model, though, it moves from approximation to exactness. Instead of just finding an answer that's close enough, it creates a direct, verifiable map from data to meaning. It's the difference between guessing what a sentence means and truly, provably knowing.
Okay, that's the tech. But what does all of this actually mean in the real world? Well, let's talk money, because the financial and energy impact is just staggering.
Let's start with training AI models. Right now, that market is worth about $50 billion a year. Because this new approach learns in a fundamentally different way, it could pretty much eliminate the need for most of that constant, expensive retraining. The potential savings, just from that, a massive $48 billion every year. And remember that whole black box problem? That whole separate industry trying to figure out what AI is thinking? Well, because this new system has transparency built in from the very start, you don't need it anymore. We're talking about a potential reduction of up to 90% in the computing power we currently waste just on AI interpretability. It's wild. And the savings just keep stacking up. On top of that huge disruption in training, you could see another 10 to 20 billion saved by making information retrieval way more efficient, and then another 20 to 40 billion from not needing as much specialized hardware. The numbers are they're huge. So what's the grand total? When you add it all up, the potential annual savings could hit $123 billion. Just let that number sink in for a second. This isn't just a small improvement. It's a complete economic reset for the entire AI industry.
And this revolution isn't just happening in the software, It completely flips the script on the physical hardware and the infrastructure that powers all of AI.
And don't just take my word for it. The source material frames the scale of this change with this stunning quote. This represents potentially the largest efficiency gain in computing history. Think about that. Not just in AI, but in the entire history of computing. We're moving from brute force guesswork to elegant, exact computation.
So what does this new world actually look like? Well, we move away from the giant centralized data centers of today. Instead, we have a distributed network. Individuals or companies can have what are called private perspective portals. Think of them as secure gateways for your own data. And these all connect to a comprehensive comprehension cloud. The main idea here is that the processing happens everywhere, efficiently, instead of in one giant power-hungry building.
So here's the infrastructure revolution in 3 simple steps. We go from these massive centralized GPU farms to a new model of distributed semantic processing that can happen all over the network. And the result? A 70 to 90% reduction in the need for all that specialized, power-hungry AI hardware. It's a total game changer.
And all of this leaves us with one last massive question. See, this paradigm shift, it isn't just about saving money or energy, as incredible as that is. It's about fundamentally changing our relationship with AI. We could be moving away from a world of probabilities and best guesses to a world of exact, verifiable meaning. So the real question is this: what will we build when our machines can finally and truly understand us?